When we are talking about experiments, especially, we have two variables. We have the explanatory variable. Explanatory is usually kind of the x-axis. It's easy to remember. And that's the thing that we're kind of testing out to see if it makes a difference. Okay, does that explain the observed outcome? And we have the response variable, which is that outcome. This deciding which is the response variable and which is the explanatory variable can be a little tricky, and so usually I tell students that the response variable is a lot easier to figure out, because you just imagine that you're there in the lab doing the experiment and you have your clipboard and you're measuring something at the end. That's your response variable. Okay? We're measuring how tall these plants grew with the different fertilizers. Well, I'm actually going to stand there with my clipboard and write down the measurement of the height of the plant. That's my response variable. What explains the differences in the heights? Oh, what fertilizer did I use? So that's my explanatory variable. So if you're having trouble, I think always trying to find the response variable first. It's a little more obvious than the explanatory variable is sometimes. We talked about the fact that in observational studies we can have confounded variables. These are variables whose effects can't be separated from one another. We're imposing our treatment, we're testing something out, we have some results. Oh, but there's something else that causes those results too, and so I don't know if it's because of the thing I was testing or this other variable. For example, let's say we're testing a new laundry detergent. And so you take a bunch of dirty laundry, and in one washing machine you use the old, regular liquid detergent, and in the new machine we're going to use those new little pods, the new little packets that have everything in one. But the machine where you wash with the old liquid detergent, you wash those clothes on cold, and with the new pod little thingies, you wash those clothes with hot water. Well, maybe one of them comes out way cleaner than the other. The problem is, I don't know if it's because of the detergent or if it's because of the water temperature. Maybe the pod did a better job of cleaning than the regular liquid detergent, or maybe these clothes came out cleaner because I used hot water instead of cold water. I can't separate the water and the soap. I can't separate the results and figure out which one really caused a difference in how clean the clothes were. So those would be confounded variables. They both kind of have the same effect, and I can't tell which one is really making the difference, which one or the other. Statistically significant is supremely important vocabulary for this class. We've had pins in the past for my stats class that say I'm statistically significant. The definition of statistically significant, a lot of times students get a little bit confused because they think to be significant we have to get like a big number for the answer, and that's not it at all. A result is statistically significant if it is too unlikely to be attributed to chance. So it's one of those situations where it's possible, but very, very, very improbable. So if you think back to the first day of school when we were talking about the pilots, right? And we had this proportion, we had more males than females in the kind of graduating class, but when they randomly chose names out of a hat, we ended up with a larger number of females, and we wanted to see if that was, if that was fishy. Well, of course it would be possible. I've got 25 people. It would be possible for me to draw 8 names and to get 5 of them to be women, or even 6 of them to be women. Okay, if we go to 6, in all of our simulations in class, nobody ever got 6. So it's possible, we know it could happen, but it didn't happen at all in almost 100 tries. So we would say that would be, if we happen to get 6 pilots that were female, that would be a result that's statistically significant, because it's really unlikely. It's possible, but it's really, really unlikely to happen. So that means it's got to be significant. It's special, or maybe it's fishy, but that's what statistically significant means. We have randomness, we have chance, we have, what could happen if I just drew the names out of a hat? Okay, but what's likely to happen, and then if it's unlikely to happen, we say that it's statistically significant. So using what you just learned about observational studies and experiments, you have this example, and it's written on your notes page, and you have a couple of questions. Does this study provide solid evidence? And could you prove or disprove cause and effect? And you should have those questions answered and be ready to talk about in class.